In this section, we're going to look at a system of equations. These are linear equations, so they make straight lines, but we're in 3 variables. And again, I want to see if this point, or an ordered triple, normally we would say an ordered pair, but there's 3 of them, so it's an ordered triple. We're going to see if this point is a solution for this system. So I'm going to try this point in all 3 equations. And if the point works in all 3, then it's a solution. But if it doesn't work in 1 or 2 of them, or all 3 of them, then it's not a solution. So we're going to be very careful. So I've got a 4x minus a 5y minus a 5z should equal a negative 22. So I'm going to substitute in my 2, 9, and negative 3. So here's my 2. Here's my 9. And here's my negative 3. And that should equal a negative 22. So 4 times 2 is 8, minus 45. So a negative 5 times 9 is negative 45. Negative 5 times negative 3 is positive 15. And that should be a negative 22. So 8 minus 45 plus 15 is negative 22. So that point works in the first equation. That means that this point is on that line. So let's see if it's on the other 2. So we're going to switch pen colors. So I've got an 8x minus a 9y plus a 5z should give me a negative 80. So an 8 times 2 minus 9 times 9 plus 5 times negative 3 should give me a negative 80. So 16 minus 81 minus 15 is a negative 80. So that works. So this point is on 2 of the 3 equations. Now we just got to see if it's on the last one. If it's on the last one, then we know that that point is a solution. Okay, so my final equation, which I'm going to scooch up 1 line, is a 4x minus an 8y minus a 3z should give me a negative 55. So 4 times the 2 I was given minus 8 times the 9 I was given minus 3 times the negative 3 I was given should give me a negative 55. So 8 minus 72, negative 8 times 9 is negative 72. Negative 3 times negative 3 is positive 9, and that gives me a negative 55. So negative 55 does equal negative 55. So since that point works in all 3 equations, this is a solution of that system, and this is a consistent system. All right, so we're going to solve this system, and we're going to use portions of what we did in a system with 2 variables. Now we're going to move it to 3 variables. So what I want to decide first is I'm going to choose a variable to kill off. Do I want to kill off x's or y's or z's? So I want to make an informed decision. So if I look, 3, 6, and 9 talk to each other easily. Okay? So those are all like multiples or factors of one another. These ones do not, and these ones do not. Okay? That's the same one, but this one is a little bit harder. So I personally am going to choose to kill off my x's, and I'm going to do it twice. Okay? So I can choose a combination of 2 equations. So I'm going to choose equation 1 and equation 2. Okay? So I'm going to choose those and kill my x's. So equation 1 is 3x minus 8y plus 5z is 27, and equation 2 is a negative 6x minus 9y plus 6z is 99. So if I want to kill off my x's, then this has a 3x and that has a negative 6x. If this was a positive 6, then those would eliminate one another. So how do I make a 3 into a 6? I multiply it by 2. So I'm going to take 2 times row 1. And that's just a little notation so I can keep track of what's going on. So my new set of equations is 2 times 3x is 6x. 2 times negative 8y is negative 16y. 2 times 5z is 10z. And 2 times 27 is 54. And then I'm going to rewrite the bottom row. So negative 6x minus 9y plus 6z is 99. And when I add those together, my x's are gone. So negative 16 and negative 9 gives me a negative 25y. 10 and 6 gives me 16z. And 54 and 99 is going to give me 153. So now if you'll notice, I'm down to an equation in 2 variables. Okay, so come back up here. Pick another set of 2 equations to kill off your x's. So I can choose 1 and 3, or I can choose 2 and 3. Well, I like 1 and 3 better because I'll just have to multiply the top row by 3. Okay, if I choose these 2, I'm going to have to multiply both rows. Okay, so I'm going to change pen colors. My top row is 3x minus 8y plus 5z is 27, and row 3 is negative 9x minus 8y plus 6z, and that's 119. So what am I going to do? I want to kill off my x's again. So I need this top row. This is a negative 9. I need him to be a positive 9. So I'm going to take 3 times the top row. So that's going to give me 9x, negative 24y, 15z, and 27 times 3 is 81. And this is a negative 9x minus 8y plus 6z is 119. So when I add those together, my x's are gone again. Negative 24, negative 8 is negative 32 y's. 15 and 6 is 21 z's. And then 81 and 119, I'm not going to try in my head because I'm too tired. 81 and 119 is going to give me 200. So I now have a new and improved 2 equations in 2 variables. So I'm going to put those 2 together and work from there. Okay, so let's introduce a new pen color. Here's black. Okay, so I'm going to use a negative 25y plus 16z needs to give me a 153, and a negative 32y plus 21z needs to give me 200. So the question is, do you want to use elimination or substitution? I prefer to use elimination, which means this is going to get a little bit ugly. Okay, so I'm going to go ahead and choose to eliminate z's. And I'm going to make it a little bit easy on myself, and I'm just going to multiply the top row by a negative 21 and the bottom row by a 16. Okay, so this will end up having a 21, this will end up having a 16, and their signs will be different. So remember, what are we going to do? We're going to say a negative 21 times row 1 and a positive 16 times row 2. Okay, so I need a negative 21 times 25 is going to give me 525. And then a negative 21 times 16 is going to give me a negative 336. And a negative 21 times 153 is going to give me a negative 3213. Okay, so that's the top row multiplied through by negative 21. I'm going to multiply the bottom row by 16. So 32 times 16, negative, gives me a negative 512. And a 16 times 21 should give me the exact same thing at 336. And 16 times 200 will give me 3200. Now look what happens. When I work vertically, I get 525 minus 512 is 13 y's. My z's are gone. And then a negative 3213 plus 3200 is a negative 13. So if I divide both sides by 13, I get y is negative 1. I know what y is. So if I know what y is, I can go back up to either of my two variable equations and I can figure out what z is. So between the red one and the blue one, I think the red one looks a little bit easier. So I've got a negative 25y plus a 16z should give me 153. Well, I know that y is negative 1. So negative 25 times negative 1 plus 16z should be 153. So that gives me 25. Plus 16z should be 153. Subtract 25 from both sides, and I get 16z. I'm running out of room. 16z is 153 minus 25. Gives me 128. And 128 divided by 16 gives me 8. So I would divide both of these by 16, and I would get z equals 8. So I know my y coordinate, I know my z coordinate. Now I just need to go back up to the top and choose what I think is the easiest one. I think the top row is the easiest row. So I am going to substitute in using a purple pen, okay? And I'm looking for x. I know that y is negative 1, and I know that z is 8. So I've got a 3x minus an 8y plus a 5z is 27. So 3x minus 8 times negative 1 plus 5 times 8 is 27. So 3x, negative 8 times negative 1 is positive 8. 5 and 8 gives me 40 equals 27. 3x plus 48 is 27. I'm going to subtract 48 from both sides. So 3x is 27, oops, sorry, 27, I just multiplied over here, is negative 21. So divide both sides by 3, and x equals negative 7. So we have a consistent system. I have a single solution, and that single solution in x, y, z order is negative 7, negative 1, and 8. Make sure it's in x, y, z order.